The F-4E is a two-seat aircraft where each crew member is responsible for different aspects of the plane. The front crew is normally the pilot and tasked with controlling and flying the aircraft and delivering its weapons. The back crew is normally the Weapon Systems Officer, WSO, and tasked with operating the radar, employing the navigation systems, and configuring weapons. On this training mission, we will study and practice the pilot's cold start procedure in detail. On a real F-4E, the cold start procedure is not just about starting engines and go fly, it is also about ensuring that each system is working correctly. This means that most steps are checks, which in DCS can be irrelevant since most of the time the aircraft has no initial faults at all. Select your preference. Press spacebar if you want to learn the full real-life procedure. Press backspace if you prefer to learn an abbreviated cold start, dispensing with most checks. Okay, you have chosen to perform all the procedure steps, including all checks and non-essential steps. Two variants of the cold start are provided on this training mission. Normal cold start, employing ground electric power and an external pneumatic air source. Autonomous cold start, employing the aircraft's electric battery and two solid propellant cartridges, not employing any ground support at all. Select your preference, press spacebar for a normal start, or press backspace for an autonomous start. You have selected an autonomous cold start, using the aircraft's battery and two solid propellant cartridges, instead of ground support equipment. We will begin this cold start procedure with the steps of the before exterior inspection section of the F-4E normal procedures. Put on the helmet that is over the right canopy rail by clicking on it. It is a bit dark at this hour. If you can't find a cockpit element, feel free to employ your flashlight, which can be toggled with left Alt+L. Another way to illuminate the cockpit at cold start is the cockpit white floodlights. They are connected directly to the battery bus, so they can be used even on a cold aircraft, but do not leave them on too long to prevent draining the battery. Finding the switch in the dark can be difficult, so you may want to assign a keyboard binding to it. On my case, I employ left Control F. Also, if the air traffic noise prevents you from hearing me clearly, you can close the canopy at any moment, as it is pneumatically operated and does not need electric power. Press spacebar to continue. Countermeasures dispenser, flare switch to normal. Operation of the dispenser is controlled from both the front and rear cockpit. The rear crew can program the CM dispenser using the CCU panel, while the front crew can do the same using the CM panel. However, for the CM programs to work, the pilot's flare switch must be placed in norm. When set to flares, the front cockpit ignores the programming and instead releases a single flare each time the pilot presses the dispense button. It does not affect the rear cockpit. Internal wing dump switch, norm. With electrical power applied to the aircraft, wing fuel will be spilled anytime the internal wing dump switch is in the dump position, even while on the ground, so make sure it is at norm. The purpose of this switch is, during an emergency, to allow fuel from the wings to be dumped directly, rather than requiring prior transfer into the fuselage. Throttle levers, off. Click on the finger lifts on the front side of each throttle to move them from off to idle and vice versa, or use the command bindings shown. Press spacebar once you confirm both throttles are at off. Battery, check. The Phantom is equipped with a 24-volt, 11 Ah nickel-cadmium battery, connected to the battery bus and, through the battery relay, to the essential 28-volt DC bus. The battery relay is closed when either engine master switch is on, or the ground refuel switch is at refuel or defuel. To confirm battery relay closure, turn on any of the engine master switches and check for proper positioning of gear, slats, and flaps position indicators, instead of the barber pole signs displayed when the switches were off. Engine master switches, back to off. The gear, slats, and flaps position indicators, return to the barber pole sign. Emergency attitude reference system, ensure the AI power circuit breaker is in. The Emergency Attitude Reference System is a backup system which provides indications of aircraft pitch and roll attitude even with the generators off, as it is powered by the aircraft battery. The adjacent knob adjusts the lighting of the standby attitude indicator on the instruments panel. External stores emergency release, check NO yellow showing inside circular guard. This button, when depressed, will jettison all external stores except special weapons and air-to-air missiles. The button should be operative only on flight conditions, but a bug on DCS has it functional even when cold on the ramp, so please do not press it or you will lose your drop tanks. Landing gear handle, in and down. Left click to move up or down, right click to move in or out. Operation of the landing gear is controlled by this handle, which has safety switches that prevent accidental retraction while on the ground. Raising and lowering the gear is done by hydraulic pressure. A red warning light in the control handle illuminates whenever the gear is changing position. Pulling the handle out will actuate the emergency mode and release the gear by using a pair of compressed air bottles. Armament switches. Off, or safe, including the armament safety override, on the left pilot wall. The station select buttons are used to activate air-to-ground munition stations and the nose gun. The master arm provides master arming function for all aircraft weapons. The armament safety override switch disables the armament safeguards. If pressed and the landing gear handle is down, it will allow, for example, to fire the gun while on ground. Selective jettison knob, off. This knob provides the pilot direct access to dump stores on a position-by-position basis. The pilot selects the desired position by rotating the knob and then presses the button on its front to jettison the selected stores. Reference ADI System Selector, set to standby. The ADI can gather its information from either of two navigation systems. Prim is the INS, standby is a less precise displacement gyroscope. Use this switch to set the ADI to use the standby navigation system, but once the INS alignment is complete it should then be switched to Prim. Digital Scan Converter Group, DSCG, display mode knob, off. The DSCG refers to the screen used to display radar data and video feed of TV weapons or targeting pods. The DSCG replaces the direct view storage tube radar scopes of earlier Phantoms, which could not interact with digital interfaces. Formation lights control knob, off. The Phantom has electroluminescent formation lights on the outer wing tips, and on both sides of the vertical stabilizer, mid-fuselage and forward fuselage. These lights are controlled by the formation lights switch and a variable control knob on the front cockpit formation lights panel. The left outer wing tip formation lights are red and the rest are green. Pitot heat, off. This switch controls operation of the heating element in the pitot head, the bellows ram air inlet probe, and the stabilator bellows venturi. The heater elements are energized anytime electrical power is applied and this switch is in the on position. Pitot heat should not be used for more than 1 minute during ground operations. Generator switches, off. 2 AC generators, one on each jet engine, are the primary source of all electrical power. Either generator can supply power to the entire bus system through an automatic bus tie relay. If one generator fails, the fault protection circuit drops it off the line and the bus tie relay energizes, allowing the remaining generator to supply power to the entire aircraft. Each generator may be manually disconnected from the system by placing its generator control switch to off. For this mission, you selected an autonomous cold start, employing the aircraft's electric battery with no help from a ground electric power unit. To connect the battery, turn on both engine master switches to close the battery relay. Do this now. Good, this last step completes the before exterior inspection section of the cold start when using battery power. Press spacebar to begin the front cockpit interior check. Rudder pedals, adjust, with crank on front pedestal. On DCS this is just an animation, for immersion purposes. You can click on the flight stick space to hide the stick, for an easier view of the crank handle. Auxiliary armament control panel, set. A. Gyro switch, norm. The pilot may fast direct the AJB-7 Euro platform by selecting the fast direct position on this switch, during level non-accelerating flight. B. Oral tone control knob, low. This is the Sidewinder's air-to-air missiles volume. C. Boarding steps position, protruding. Indicates the boarding steps are raised. Slats override switch, norm, guard closed. With this switch in norm, the wing slats operate automatically as a function of angle of attack, though they can be extended manually if desired by the pilot. If this switch is placed at in, the slats are retracted regardless of AOA or the slats flap switch position. Intercom control panel, set. Intercommunications between the aircrew and with the ground crew is provided by the intercom system. Volume control, as desired. The input level of the intercom signals to the headsets is adjusted with this knob. Signals received from other radio receivers are not affected. Amplifier selector knob, norm. Each cockpit is provided with a primary and secondary amplifier. If a primary amplifier becomes inoperative, communications may be restored by selecting the secondary amplifier with the backup or emergency positions of this knob. Function selector switch, set to hot mic. The hot mic position allows automatic operation of the intercom. Cold mic is for manual intercom use, with the crew needing to switch the microphone button on the throttle to its ICS position to talk. The radio override position is identical to hot mic, except that other radio communications are reduced in volume. Stability augmentation switches, yaw, roll, and pitch. All off. With these switches, stability augmentation can be enabled for the 3 axes, in any combination. When enabled, the system decreases any tendency of the aircraft to oscillate in roll, yaw, or pitch, and also reduces unintended aircraft slip or skid. Fuel control panel, set. Fuel is carried internally in a 1,225 gallons fuselage tank, made up of 7 interconnected cells, and 2 internal wing tanks. External fuel is carried in drop tanks, 2 370 gallons under each wing, and a 600 gallons under the fuselage. The fuselage cells are arranged so cell 1, the engine feed cell, is behind the aft bulkhead of the rear cockpit. The remaining cells are numbered consecutively, with cell 7 being the aftmost one. Cells 4 and 6 each contain 1 hydraulic and 1 electric fuel transfer pump, to transfer fuselage fuel to cells 1 and 2. Regulated engine bleed air pressure transfers internal wing fuel and all external fuel to the fuselage cells. Fuel will not transfer from internal wing or external tanks, until the weight is off the gear and the tanks are pressurized. Air pressure is also used to facilitate dumping internal wing fuel, and to maintain a positive pressure in all tanks. Cells 2 through 6 are so arranged that they will gravity flow into cell 1, with the exception of approximately 1,500 pounds, if a complete transfer pump failure occurs. The fuselage cells and internal wing tanks contain fuel gauging units, which read out in pounds on the fuel quantity indicator. Press spacebar to continue. Internal wing transfer switch, normal. Fuel carried in the internal wing tanks and all external tanks is transferred by air pressure to the fuselage cells, providing the weight is off the gear and the tanks are pressurized. In normal, the wing tank valves are open, allowing internal wing fuel to transfer to fuselage cells 1 and 3. In stop trans, the valves are closed, stopping transfer of internal wing fuel to the fuselage cells. External transfer switch, set to off if no external tanks, or OBD, outboard, if you have external wing tanks. Never enable a center tank while on the ground. If the external transfer switch is placed to a position on which tanks are not installed, internal wing fuel will transfer in the normal manner, provided the internal wing transfer switch is in the normal position. Internal wing dump switch, norm. Wing fuel may be dumped in flight at any time, regardless of any other transfer switch positions, by placing the hex head dump switch to dump. At 85% RPM in level flight, the fuel dumping capability is approximately 650 pounds per minute. Air refuel switch, retract. The air refueling system utilizes a receptacle, aft of the rear cockpit, above the number 2 fuselage fuel cell. Actuation of the receptacle is controlled by this switch. Extends the receptacle, interrupts the fuel control panel continuity, and illuminates the air refuel ready light. When the receptacle is extended, the external air refueling lights illuminate. Placing the switch on retract restores continuity to the fuel control panel and retracts the boom receptacle. Refuel selection switch, set to all tanks. The int-only position closes the external tank's fuel shutoff valves, allowing only the fuselage and wing tanks to be refueled. The all tanks position opens also the external tank's fuel shutoff valves, allowing all fuel tanks to be refueled. Press spacebar to continue. The next 4 check items are designed to prevent any sudden movement of these surfaces when the engine starts, to avoid ground crew injuries. Flaps slats switch, up or norm. The slats and flaps system provides an automatic slat configuration for in-flight maneuvering, and a selective slat flap configuration for takeoff and landing. With the switch in norm, the maneuvering slats operate automatically as a function of angle of attack. If desired, the slats may be extended manually by selecting out on the switch. However, at speeds above approximately 570 knots the slats will still retract automatically. The out and down position extends the slats out and the flaps to the down position, for takeoff and landing. Emergency flaps slats handle, forward. Emergency extension of the slats flaps, in case of no hydraulic power, is accomplished pneumatically by high-pressure air from an emergency air storage bottle, when pulling either emergency flap extension handle aft. The air bottle contains sufficient air for only one extension. Drag chute control handle, down and secure. A 16-foot drag chute, contained in the tail cone, significantly reduces landing roll distances. The drag chute may also be used for out-of-control/spin recovery, and it is normally deployed after each landing. On DCS, clicking the handle raises it to its detent, releases the door latch, the pilot chute pops out, pulling out and deploying the larger drag chute. You can also use the key P to operate the handle. Do not operate it now, as it can be used on a cold start but it will leave the tail cone open. With the handle raised, a secondary handle comes into view, with a button on its end. The drag chute can be jettisoned by clicking on this button, or using the keys right Shift plus P. The release and jettison mechanism then returns to its normal position, permitting the drag chute to pull free. Speed brake switch, in. Hydraulically operated speed brake panels are mounted on the underside of the inboard wing surfaces. They are actuated by a 3-position switch on the throttle, with positions out, stop, and in. The out position is momentary and reverts to stop when released. A warning light, speed brake out, illuminates when either or both speed brakes are not fully closed. Communication antenna selector switch, upper. Electromagnetic interference radiating from the lower UHF antenna may interfere with the nose wheel steering system. Therefore, the upper UHF antenna should be used anytime the aircraft is not airborne. Engine anti-icing switch, normal. Engine bleed air is employed to prevent the formation of ice on the engine frontal area. The bleed air flows through small orifices and enters the engine primary airstream. The system is an anti-icing, not a de-icing system, since an actual buildup of ice will block the orifices and render the system inoperative. Engine anti-ice is not needed or desired at high Mach numbers since the compressor inlet temperature is sufficient to prevent any ice accumulation. On the warning panel, the lights for left and right, anti-ice on, illuminate when the system is enabled. If the lights illuminate during flight, with the anti-icing switch in normal, the anti-icing shutoff valve has failed in its open position. Oxygen supply system, check and set. On the Phantom, breathing oxygen is supplied by a 10-liter liquid oxygen system. The system consists of a converter, a coil to convert from liquid to gaseous oxygen and a console-mounted pressure demand regulator in each cockpit. The regulator automatically controls the pressure and rate of flow of oxygen based on demand and altitude. It provides a proper mixture of air and oxygen at low altitudes, and pressure oxygen at high altitudes. Oxygen supply lever, fully on. This lever controls the oxygen flow, on or off, from the regulator. Diluter lever, normal. This lever controls the mixture of air and oxygen. For a proportional amount of air to oxygen, the normal position should be selected. For only oxygen, the 100% oxygen position is used. Emergency lever, normal. Usually set to normal, the emergency position provides continuous air pressure to the face mask for emergency use. The test mask position provides positive pressure to test the face mask for leaks. Check the oxygen pressure gauge. The oxygen system pressure should indicate between 50 and 125 psi until the converter is depleted. Put mask on and hold the emergency lever in its test mask position. Breathe normally and check flow indicator operation. A white indicator indicates flow due to a leak that must be corrected before flight. Return the emergency lever to normal. Good, this finishes the checking of the oxygen regulator. Press spacebar to continue. Aileron rudder interconnect, ARI, circuit breaker, check it's in. The ARI system makes rudder movements to be proportional to aileron displacement, which provides coordinated turns at low air speeds. To disengage the ARI, this circuit breaker must be pulled out, plus the yaw stability augmentation switch must also be disengaged. Pulling the CB only, and keeping the yaw augmentation enabled, will still provide 5 degrees of ARI rudder authority. Landing and taxi light switch, off. The landing and taxi lights are on the forward nose gear door. The left main landing gear must be down for operation of either light. Emergency brake control handle, in and secure. Pulling the emergency brake handle in either cockpit discharges the brake system hydraulic accumulator, providing emergency braking to the brake pedals, with normal feel but with a limited number of applications. Because of this limited number of applications, taxiing should not be attempted when using the emergency brakes. Canopy emergency jettison handle, forward. The canopies are jettisoned by compressed air supplied from the basic pneumatic system to 2 independent canopy jettison systems, 1 for each cockpit. Canopy jettison takes place on 3 situations: when the crew ejection seat is fired, when the emergency canopy jettison handle is pulled by either crew to get out of the aircraft after a forced landing, or when the external canopy jettison handle is actuated by rescuers. Clock, wind, and set. A clock is provided for the pilot, including a stopwatch function. The clock time is set with the highlighted knob, however on DCS it is already set to the mission's start time. The stopwatch is started, stopped and reset by successively pressing the top right button. Flight instruments light control, off. Not yet simulated, it will be made available later during early access. For now leave the knob fully counterclockwise, which is the off position, so that the warning and indication lamps are at full brightness and not dim. Multiple weapons control panel, set. Master arm switch, safe. Provides master arming function for all aircraft weapons. Delivery mode knob, off. The delivery mode knob is used to set the release mode for bombing. Values to the left of off employ the AJB7, attitude reference and bombing computer set, ARBCS, whereas values to the right of direct employ the weapon release computer set, WRCS. Direct is the manual release mode. Weapon select knob, C. The weapon selector knob is used to designate the type of weapon to be used. C is an unused position, which can be used as an off selection. Radar missile power switch, off. This switch is used to tune the Sparrow missiles. We will learn its use during the weapons training missions. Interlock switch, in. With in selected, the Sparrow missiles will not release upon trigger down, unless valid launching parameters are met. It has no function for Sidewinder launch. Standby attitude indicator, check. The SAI functions independent of the flight director group, providing reasonably accurate readings if power to the system is lost and the off flag is in view. Roll is shown through 360 degrees, while pitch is limited at 92 degrees in climb and 78 degrees in dive, to prevent gimbal lock. Uncage with a left click. Set miniature aircraft level with the horizon bar, using the mouse wheel. Navigation Function Selector Panel, set. Controls display presentation on the ADI and HDI based on the selected position of the two knobs. The bearing and distance knob determines the source of navigation information, while the mode selector knob provides control over the presentation of various displayed information. The mode selector knob includes an inset switch marked FD, for flight director. This switch engages or deactivates the pitch and bank steering bars on the ADI. The off position has the switch aligned vertically. Set both knobs as desired. Fire warning lights, test. The fire and overheat warning lamps, one for each engine, are a pair of two-position indicators that illuminate when a fire condition is detected in the engine compartment, or an overheat condition is detected in the exhaust nozzle section. When pressed and held, this button tests that the fire and overheat lamps are not burnt out. Do it now. If the lamps are okay, then all four lights should light up, for as long as the button is kept pressed down. Release it now. The button can also be used in conjunction with the warning lights test switch to check detection and continuity loops of the fire and overheat warning systems. Hold the warning lights test switch in the warn test position by pressing the right mouse button on it. Now, without releasing the right mouse button, perform the continuity test by simultaneously press and hold the fire test button with the left mouse button. Proper system function is confirmed if the four fire and overheat lamps go out while the fire test button is pressed, then illuminating again once the left mouse button is released. Release the right mouse button to continue. If the warning lights test switch does not spring return to off, click on it to release. Good, the fire and overheat warning system has passed the check. Press spacebar to continue. Accelerometer, reset to 1G by pressing its knob. The indicator has three movable pointers, one for current G load, while the other two record the maximum positive and negative G load attained. Canopy manual unlock handle, forward. The manual unlock handle is used in the event of pneumatic system failure. The handle, when pulled aft, unlocks the canopy so that it may be pushed open. Before manual unlocking of the canopy, the normal control lever must be placed in the open position. Arresting hook control handle, up. Pulling the handle down extends the tail hook, which is utilized for field emergency arrestment. The F-4E does not support carrier operations. Emergency vent knob, in. Should only be used if the pressurization system is malfunctioning and reads abnormal values, or to eliminate smoke and fumes from the cockpit. Descend to safe altitudes before activating. Rain removal switch, off. When activated, bleed air from the engine is rerouted around the canopy to blow away any rain drops. Should not be used during dry conditions, as the hot air will heat up the windshield. If the glass reaches critical temperatures, the windshield temp high warning will illuminate on the warning panel. Defog foot heat control handle, as desired. This lever routes warm air to the windshield for de-icing purposes, or to footwell recesses for crew comfort. DCU-94A, bomb control monitor panel, set. In real life, this panel is used to control and test the separate release circuit system for nuclear stores. Nuclear stores are separated from the regular release system to prevent accidental release. This panel is not simulated on DCS. Temperature control panel, set. Temperature control knob, as desired. Mode selector switch, auto. When the mode switch is in the auto position, the knob allows the pilot to set the temperature inside both cockpits from cold to hot for crew comfort. Should the auto system fail, the switch can be placed in either a manual mode, or on its center position, which turns the system off. Cockpit lights control panel, as required. White floodlight switch, off. This switch activates a separate emergency floodlight, also called thunderstorm light, that illuminates the cockpit in white. It is connected directly to the battery, so you can use it on a cold and dark cockpit to quickly illuminate the whole cockpit. Instrument panel lights control knob, as required. This knob adjusts the background illumination of the instrument panel, as well as edge lighting for most of its gauges. Console lights control knob, as required. Ranges from off to brightest, and adjusts the illumination level for the left and right console. Standby compass light switch, as required. It's a 3-position switch. In the warn LT test position tests the various emergency indicators in the cockpit. In the standby comp position, it illuminates the light for the standby compass. Console floodlight switch, as required. It controls the lighting level of red floodlights for the consoles. 3 settings are available: dim, medium, and bright. To turn them off, place the switch in dim and the console knob in off. Floodlights for the instrument panel are found on the right wall. Indexer lights control knob, as required. This knob is located on the nearby lighting panel on the right cockpit wall. It adjusts the illumination of the angle of attack indexers on both sides of the windscreen. Marked positions are dim and bright, with the highest level to the right of the knob. Compass control panel, set. The Phantom has 2 sources of azimuth and attitude reference. The INS is the primary source of this data, while the AJB7 Euro compass is the backup source. This panel contains controls for the proper operation of the AJB7 backup. Latitude compensator, set to 0, to avoid errors by doubling drift compensation due to INS corrections. Mode control knob, set to slaved. Slaved is the primary operational mode under typical conditions, set to compass, if the INS primary system fails, as it will supply magnetic heading from the Euro compass. If the reference system is set to standby, and the aircraft is operating on extreme latitudes, then set the mode to DG, directional Euro, and set the lat knob to adjust the latitude. The sync mode speeds up the synchronization between the compass and the primary reference. The degree of synchronization is indicated by the sync indicator. Synchronization indicator, check. It displays the azimuth deviation between the flux valve signal and the internal reference system. Exterior lights control panel, set. Fuselage light switch, as required. This switch controls 3 semi-flush white lights on the fuselage, plus a red anti-collision light on the vertical stabilizer. The anti-collision light illuminates only when the fuselage switch is in bright and the flash switch is in the flash position. Exterior lights flasher switch, as required. Setting this switch to its flash position causes the fuselage, anti-collision, and tail lights to flash. Tail and wing light switches, as required. A green light and a red light on the wing tips, plus a white light on the tip of the tail, comprise the position lights. Additional green and red lights on the trailing edge of each wing tip are join-up lights. Both the wing and join-up lights are controlled by the wing switch, while the tail switch controls the tail light. Instrument lights intensity control panel, set. The knobs on this panel can be used to tweak brightness for instruments individually, where the fully counterclockwise position turns them off and moving the knob clockwise progressively increases brightness until it reaches the level dictated by the flight brightness knob. On DCS their effect is not implemented yet. Circuit breakers. Confirm that all CBs are pushed in. Intercom system, check with help from the crew chief. Press A to call up the crew chief menu, then select crew chief, and then comms checks. Press spacebar once the crew acknowledges.
Loud and clear.
Good, this completes the front cockpit interior check. Press spacebar to proceed with the before starting engines procedure. Communication, navigation, and identification, CNI, switch, on. Have ground personnel place the CNI switch in the left wheel well to the on position. On early access this step is done automatically by the ground crew. When the CNI equipment is operating on external power without cooling air applied, it is limited to 10 minutes of accumulated operation in a 1-hour period in order to prevent heat damage to the equipment. Fore and aft area, clear. Ensure the wheels are chocked, the engine intake and exhaust areas, the starter exhaust areas, and both cockpit and canopy rail areas are clear of personnel and equipment. Fire guard, posted. Check that the fire extinguishers are being manned by the ground crew. Throttles, off. Double check that both throttles are on their off position. Press spacebar to begin the starting engines procedure. The real aircraft start procedure establishes the right engine as being started first, to ascertain that both utility hydraulic system pumps are operating properly. The right engine pump delivers 2,775 plus minus 225 psi at idle, while the left engine pump delivers 3,000 plus minus 250 psi. Because of this, the single needle utility hydraulic pressure indicator cannot be used to determine pump operation, unless the right engine is started first. As our UHF radio does not function with just battery power, we will start engines without asking for air traffic controller clearance. The engines can be started by utilizing electrical power from either an external power source or from the aircraft battery, and by utilizing air pressure from a ground cart or from a solid propellant cartridge. For this training mission, we will employ just the aircraft battery and a solid propellant cartridge. Cartridge air source, ask ground crew to load start cartridges. On DC, good, now select crew chief, then air source, and finally select load start cartridges. Press spacebar once you hear the crew chief confirming that cartridges for both engines have been loaded.
Roger. Cart's loaded, sir.
To start each engine, once its RPM reaches 10%, you will need to simultaneously move the throttle from stop to beyond idle, while keeping its ignition button pressed. While you can move the throttle from off to idle by clicking on its finger lifts, and then advance it by moving forward your HOTAS throttle lever, make sure to bind at least the ignition buttons, to make it easier to perform these three actions on a single take. Press spacebar to continue. Right generator control switch, set to Gen on. Later, when the right engine reaches over 53% RPM, the generator will start to provide electric power to the aircraft. Right ignition button, depress and hold the right ignition button, and simultaneously advance the throttle to a position halfway up the throttle quadrant. Engine start switch, flick momentarily to its right position, with a right mouse click. Do not release the ignition button yet. This will fire the right cartridge, a bang sound will be heard. Then, release the engine start switch to its central position. Monitor the engine's RPM and temperature, for indications that light-off has occurred. Release the ignition button as soon as a sharp rise in EGT indicates light-off. Idle RPM is reached at 65 plus minus 1%. Fuel flow indicator, check it's within limits. Fuel flow should not exceed 750 pounds per hour at light-off, and 800 to 1400 pph at idle. Fuel consumed during starting is approximately 65 pounds per engine. Exhaust gas temperature indicator, check it's between 220 to 420 degrees Celsius. Right fuel boost pump indicator should be 30 plus minus 5 psi. Oil pressure indication, it should be a minimum of 12 psi. Hydraulic pressure indicators, check they are within limits. With just the right engine started, the PC2 hydraulic pressure indicator should read 3000 plus minus 250 psi, and the utility hydraulic pressure indicator should read 2775 plus minus 225 psi. The check hydraulic gauge indicator light remains illuminated until the left engine is started and all four hydraulic pumps are operating above 1750 psi. Once the left engine is started, the utility hydraulic pressure indicator will read 3000 plus minus 250 psi. Press spacebar to continue. Spoiler actuator, check. This check is done with help from the ground crew. Press A to call up the crew chief menu, or set the mic switch aft on your HOTAS throttle. Good, now select crew chief, then ground checks, and finally select spoiler actuator. Press spacebar once the crew chief is ready.
Ready, sir.
Next, slowly deflect the flight stick approximately 1 inch to the left, do not push the stick too far. If the ground crew says that the check went wrong, because you pushed the stick too far, repeat the test by calling up the menu again. The check is successful if the crew says that the spoiler has a partial deflection. Return the stick to neutral. The crew should report that the spoiler returns to a flush
Okay,
position.
partial deflection.
Press spacebar to continue.
Yep, retracted.
Left ignition button, depress and hold the button, and simultaneously advance the left throttle to a position halfway up the throttle quadrant. Engine start switch, flick momentarily to its left position with a left mouse click. Do not release the ignition button yet. This will fire the left cartridge, a bang sound will be heard. Release the engine start switch to its central position. Monitor the engine's RPM and temperature for indications that light off has occurred. Release the ignition button as soon as a sharp rise in EGT indicates light off. Idle RPM is reached at 65 ±1%. Fuel flow indicator, within limits. Fuel flow should not exceed 750 pounds per hour at light off, and 800 to 1400 pph at idle. Exhaust gas temperature indicator, check it's between 220 to 420 degrees Celsius. Left boost pump indicator, should display 30 ±5 psi. Oil pressure indication, it should be a minimum of 12 psi. Hydraulic pressure indicators, check they are within limits. With the left engine started, both the PC1 and 2, and the utility hydraulic pressure indicators, should read 3000 ± 250 psi, and the check hydraulic gauge indicator light should have gone out. Press spacebar to continue. Left generator control switch, set to on. Ensure both LH gen out and bus tie open lights go out, and that INS is not in the align mode yet. Once both generators are active, on DCS single player mode Jester will ask if you are ready to begin the alignment. Use the mouse to click within its red circle and then confirm by clicking on it.
If you cycle Gen 2, I can start the alignment. Roger.
Next, Jester will ask which alignment.
Alright, what alignment do you want?
Its red circle. Jester will then offer 3 alignment options. Full alignment, for the greatest INS precision but takes around 8 minutes to align. Best available true heading, back, takes only a bit over 2 minutes but it has around half the precision. Heading memory alignment is offered only if there is prior alignment data on the system, takes the same time as back but its precision is closer to the full alignments. Select the one you want by clicking on it, and Jester will carry out the alignment. Press spacebar to continue.
Full alignment, you got it.
Right generator control switch, cycle. Turn right generator control switch off and check that the RH gen out light illuminates, to denote that the generator is disconnected from the bus system. Bus tie open, light out. Ensure that the light, bus tie open, remains out when placing the right generator control switch to off, and that it flashes on momentarily when the switch is returned to the gen on position. That's a good generator check. Press spacebar to continue. Interior check, complete. Perform the steps and checks that couldn't be done when starting on battery alone. Press spacebar to continue. Ejection seat height, adjust as desired. The ejection seat may be adjusted vertically only, by actuating a momentary contact switch on the right forward side of the seat. Left click to raise, right click to lower. The seat can be adjusted through a total distance of 6 inches. VORILS control panel, set and test. The VHF omnidirectional range, VOR, instrument landing system, ILS, provides precise bearing and course deviation information from a transmitting ground station.
Canopy down and locked, lights out and stripes aligned.
It is able to use precision landing approach and descent capabilities at ILS-equipped airfields. Guidance information from the VORILS system is displayed to the pilot on the ADI and HSI, while the Weapons Systems Officer, WSO, uses a BDHI. The VORILS function is enabled on these displays when VORILS is selected on the bearing distance, and on the navigation mode selector. Set the VOR receptor as follows. Volume control knob, as desired. This knob serves also as power switch. When turning it clockwise, make sure to turn it, in order to power up the receptor. Marker volume knob, as desired. This knob adjusts the audio volume of the marker beacon receptor. Marker beacons are radio transmitters positioned along the landing approach path. The system will audibly signal and illuminate the marker beacon light as it passes over each one. Frequency. For this mission we will tune Karuna's VOR. Its frequency is 115.20 MHz. The frequency knob has two controls. Its outer ring selects the integer part of the frequency, whereas the inner knob selects the decimal part. Use both to select the 115.20 value on the display. VOR marker beacon test switch. Press and hold to test. This button allows us to test the receptor, employing the signal from the VOR station shown on the display, but before the test you must set up the following conditions. On the navigation selector panel, set bearing distance to VOR tack. In this setting, magnetic and relative bearing to the VOR station are displayed by the HSI bearing pointer. Mode to VORILS. On this mode, if a VOR frequency is selected, the HSI course set knob is used to set the VOR radial. Once set, the HSI deviation indicator will show current deviation from the selected course. Next, use the course set knob of the HSI to select a course of 315 degrees. That's all. Now you can press and hold the VOR marker test button. On the HSI, the course deviation indicator should move to center. The to, from, indicator should indicate to. The bearing pointer on the HSI should swing to 315 degrees. And the marker beacon light illuminates briefly. Press spacebar once you have finished the test. Boost pumps and engine fuel shutoff valve, check. Hold the left boost pump switch on its check position, and observe that the left boost pump pressure indicator reads 30 ± 5 psi. Also, note that zero fuel flow is registered on the left fuel flow indicator. Allow 3 seconds after releasing the left switch, then repeat the procedure using the right boost pump check switch. Ensure boost pump check switches return to the normal position after actuation. Anti-skid, check. The aircraft is equipped with an anti-skid system which prevents skids and can provide consistently shorter landing rolls for all runway conditions. The system is activated by placing the anti-skid control switch on and lowering the landing gear. It may be disengaged by placing the anti-skid switch to off, or by holding the emergency quick release lever pressed. An anti-skid inoperative light illuminates when the system is not activated. Anti-skid switch, on. The anti-skid inoperative light should be off. Emergency quick release lever, on the flight stick. Press and hold, the light should illuminate. Release the lever, the light should go off. Anti-skid switch, off. The light should go on again. Oxygen quantity gauge, check. The gauge has a range from 0 to 10 liters. Check that the current quantity is sufficient for the intended mission, the off flag on the gauge face is not visible, and the oxygen low warning light is extinguished. We will now test the oxygen gauge, starting by clearing the master caution light. Next, press and hold the oxygen test button, the gauge needle should move to an indication of 0. Check that the oxygen low and the master caution lights illuminate at 1 liter. Release the test button once the gauge reaches 0. The warning lights will turn off once the needle moves above 1 liter again. Optical sight, set its mode to cage and adjust its brightness. The Lead Computing Optical Sight System, LCOS, is used to establish a visual sight reference for either air-to-air or air-to-ground weapons delivery. A red reticle is projected on a combining glass. The LCOS features 7 different modes that can be selected via this knob. On the cage position, the reticle is displayed and caged at the radar bore sight line. Rotate the reticle intensity control knob to adjust the brightness of the reticle. ADI, check and set. The ADI includes an attitude sphere, turn indicator, steering bars, miniature aircraft, glide slope pointer, flags, and a pitch trim knob. It displays pitch bank and heading from the selected reference system, and allows pitch adjustment via the trim knob. Rotate its pitch trim knob to check travel, and set horizon bar level with the miniature aircraft. Fuel quantity gauge, check. The fuel quantity indicator provides 2 readings for internal fuel. A top white tape displays the total usable fuselage fuel, with a scale marked 0 to 10,000 pounds. This amount does not include the reserve fuel cell 7. A numeric counter displays the entire internal fuel in 10-pound increments. This means all fuselage cells, including the reserve one, plus the 2 internal wing tanks. The fuel quantity on external tanks cannot be checked. Actuate and hold the feed tank check switch to check fuel quantity in the feed tank. The indicated value should read 1400 plus minus 200 pounds on the counter, and the tape value should be 1400 plus minus 150 pounds. RWR systems, check as required, then off. Press the system power button to turn on the ALR-46 radar warning receiver. When pressed, the RWR control panel and its display will go through a warm-up, with the illuminated buttons flashing. The ALR-46 radar warning receiver, or simply RWR, is our passive defensive system for detection of airborne and surface-to-air radar threats. It receives signals from multiple antennas installed at the aft of the fuselage, on each wingtip and under the nose, which are used by the system to determine a bearing to the emitting radar. Further processing of the signal against a stored threat catalog ascertains emitter type, as well as relative threat range. The resulting processed threat signal is then presented on the RWR CRT display, with bearing to the emitter shown on the display with the top relative to the nose, 12 o'clock, and the bottom to the tail, 6 o'clock, and with proximity to center relative to the system's calculation of the level of threat, with closer indications being of higher danger. In normal operation, the RWR can display 16 threats concurrently. Once the RWR is warmed up, its lights have stopped flashing. Press its Sys Test button to initiate a self-test. The test provides a 3-band check, 1 low, 2 mid, 3 high, in all 4 quadrants for proper sensitivity, along with an angle confirmation of 225-degree relative bearing for diagnostic purposes. Turn both knobs to adjust the RWR display brightness and the audio level of its warning sound. Once the test finishes, turn off the RWR. Communications and Navigation Control Panel, set. The ASQ-19A is an integrated electronic central which combines the communication, navigation, and identification systems into one unit. The communication functions are provided by a UHF receiver transmitter, an auxiliary UHF receiver, and an intercom set. Navigation functions are provided by a TACAN receiver, plus an automatic direction finding feature, ADF. Later F-4E also contained a VOR ILS system, but it is not part of this set. Instead it is mounted separately on the left console. An Identification Friend or Foe set, IFF, provides coded radar identification of the aircraft when challenged. When the CNI equipment is operating on external power without ground cooling, it is limited to 10 minutes of accumulated operation in a 1-hour period. This limit does not apply to the intercom system. On the TACAN control panel, set. Navigation channel control knobs, as required. Navigation volume control knobs, as desired. TACAN function selector knob, off. For this training mission, we will be using the BANAC TACAN, so tune the unit to employ the 47 X-ray channel. The UHF radio provides both voice communication, AM, and automatic direction finding capabilities, ADF. It comprises 2 main units, a radio transmitter receiver, COM, and a receiver unit, referred to as auxiliary, plus a guard receiver. The COM unit can be manually tuned on a frequency range from 225 to 399.95 MHz, while also having 18 preset channels. The auxiliary unit is designed to receive signals on 20 preset frequency channels, ranging from 265 to 284.9 MHz, but it can't be manually tuned. Both the COM and auxiliary receivers have the capability to process ADF signals, which can be displayed on the horizontal situation indicator, HSI, or bearing distance heading indicator, BDHI. Communication frequency control knobs, as required. For this mission, tune the ATC frequency of our destination airbase, at Banak, which is 250.20 MHz. Communication channel control knob, as required. We can also employ a preset frequency, instead of a manual one. Select preset 2, which corresponds to Bodo Airbase's air traffic control, ATC. Mode select switch, as required. For this mission, set it to TR+G, to employ the radio just for voice communications, not ADF. Set the remaining UHF controls. Communication volume control knob, auxiliary channel control knob, and auxiliary volume control knob, set as desired. Both the front and the rear cockpit have a control panel for these systems, but only one at a time is in command of the radio. Communication command button, as desired. Navigation command button, as desired. For this mission, set the command to the front cockpit. Both buttons should illuminate in green. Pitot heat, check with help from the crew chief, then turn it off. We will now check if the pitot heating system is working. First, turn the switch to on. Next, press A to call up the crew chief menu. Select crew chief, then ground checks, and then pitot heat. Press
Roger.
spacebar once the ground crew reports that the pitot tube is warm.
Pitot looking good.
That's a good check. Now turn the switch off. For normal operations, the pitot heat should always be activated prior to takeoff, but not left on while on the ground for longer than 1 minute, to prevent damage due to overheating. Due to DCS limitations, the identification friend-foe system is not fully simulated, but its controls can be manipulated so that the player can get a feeling for how the real aircraft's IFF is operated. The Phantom is equipped with a set of interrogator systems, as well as with a transponder to react to interrogations from other units, automatically responding to challenges from surface or airborne radar sets. The system operates by receiving coded interrogation signals and transmitting coded response signals to the source of the challenge, with a proper reply indicating the target is friendly. The system features 4 modes, Mode 1, Mode 2, and Mode 3A, which are provided for security identification, personal identification, and traffic
Prime sync clear, go ahead. Ready to taxi.
Mode 4 is controlled through the interrogator panel of the Weapons Systems Officer. IFF Master Control Knob, off. Check that the master knob is set to off. Warning and indicator lights, test. Right-click and hold the warning lights test switch. All warning lights should illuminate. Communication and navigation equipment, turn on and check. TACAN, set to transmit, receive and tune the desired station. For this mission, set it to 47 X-ray, for Banak Air Base. UHF radio, set to TR+G, and tune the desired station. Today we will set it to preset number 2, for Bodo ATC. IFF, check. Prior to this point, the IFF should have remained off, as any interruption of power would cause loss of the Mode 4 code entered by the WSO. Set to standby. Radar altimeter, turn on and check. Function control switch, set to on by turning its knob clockwise. Check that the off flag moves out of view. Function control switch, depress and hold, to perform a radar altimeter self-test. Check that its pointer moves to 35 ± 15 feet and stabilizes. Low altitude warning light, check. While keeping the function control switch depressed, turn the knob with the mouse wheel, to move the reference marker above and below the altimeter pointer. The warning light must illuminate within ± 5 feet of the indicated altitude. Function control switch, release. Move the reference marker to below 5 feet. Check that the warning light is off. Reference marker, set. Enter the desired low altitude limit, for example set it to 200 feet. Press spacebar to continue. Speed brakes, cycle. Open and close the speed brakes to check proper operation. The ground crew will check that speed brakes extend simultaneously. Observe that the speed breakout indicator light is extinguished when they are closed.
Speed brakes out. Speed brakes in.
That's a good check. Press spacebar to continue. Slats and flaps, check. Place slats flaps switch to out. Observe that slats indicate out and flaps indicate down.
Slats out. Flaps down.
Place slats override switch to in. Observe slats retract.
Slats in.
Place slats override switch back to norm and close its cover. Observe slats extend.
Slats out.
If slats indicate barber pole or indication does not match switch position, leave switch as set and abort the mission. Flight controls, check. This check should be performed with slats and flaps out and down, and the pitch trim should be set between 1 to 3 units nose down. Set this desired trim by pushing forward on the flight stick's trim hat, while keeping an eye on the pitch trim gauge. Next, ask ground crew to help with this check, by selecting crew chief, then ground checks, and finally select flight controls. Press spacebar once the crew chief is ready.
Ready.
Control stick, pull full aft and release. Ground crew should confirm all flight control positions. The master caution and check hydro gauges lights may illuminate momentarily during this check.
Stab up. Stab down.
Rudder, check full travel left and right. The chief should report the rudder positions.
Rudder left. Rudder right.
Ailerons and aileron rudder interconnection, check. Move the control stick full left and hold it there. The left spoiler goes up, right aileron down, and rudder slightly left. The ground crew should call roll left.
Roll left.
Without releasing the stick left, engage the yaw stab augmentation. The rudder will move further left. The crew will call rudder tick.
Rudder kick.
Good, now press the emergency quick release lever on the flight stick. The rudder will move towards neutral and the crew should confirm.
Rudder neutral.
Release the emergency quick release lever, neutralize the flight stick and disengage the yaw stab augmentation. Now we will repeat the check with the right side. Move the control stick full right and hold it there. The right spoiler goes up, left
Roll
aileron
right.
down, and rudder slightly right. The ground crew should call roll right. Without releasing the stick right, engage the yaw stab augmentation. The rudder will move further right and the crew will call rudder tick.
Kick.
Good, now press the emergency quick release lever on the flight stick. The rudder will move towards neutral and the crew should confirm.
Rudder neutral.
Release the emergency quick release lever, neutralize the flight stick and disengage the yaw stab augmentation. Good, this completes the flight controls check. Press space, slats flaps, norm. The aileron rudder interconnect, ARI, should disengage automatically when the slats flaps are up. Ask ground crew to help with this check, by selecting crew chief, then ground checks, and finally select ARI disengage. Press
ready.
spacebar once the crew chief is ready. ARI disengage, check. Confirm the ARI is disengaged by moving the stick full right and left. The crew should report no rudder movement. Press spacebar once the check is complete.
Nothing's moving. Flaps up. Slats
Stability
in.
augmentation switches, engage and check. As before, ask ground crew to help with this check, by selecting crew chief, then ground checks, and finally select stab augmentation. Press
Ready.
spacebar once the ground crew is ready. Engage each axis of stab augmentation individually. The crew should observe no movement of any control surface.
Nothing's moving. Nothing's moving. No movement.
That's a good check. Press spacebar to continue. Compass mode control knob, sync if necessary. Sync is not needed if the sync indicator dial is on its neutral position. To sync, turn the mode dial to its sync position and hold it there for a few seconds. Automatic Flight Control System, AFCS, check. The AFCS is an electro-hydraulic system capable of performing two modes of operation, stability augmentation and autopilot. This latter mode maintains the current aircraft heading and/or attitude within the AFCS limits. Its altitude hold submode keeps the current barometric altitude while in the AFCS mode. The AFCS requires the stability augmentation switches enabled, so let's turn them all on. AFCS, engage. Check that neither the stick nor any control surface move after its engagement. Now, move the control stick forward or aft and check that the AFCS switch disengages. Re-engage the AFCS switch. Altitude hold, engage. Check that neither the stick nor any control surface move after its engagement. AFCS, disengage. Depress and hold the emergency quick release lever on the flight stick. Observe the two autopilot switches automatically turn off, and the lights, pitch augmentation off, autopilot disengage, and master caution, illuminate. Release the lever. Observe the light, pitch August off, goes out. Stability augmentation switches, disengage. We will turn them on once we begin the taxi. Trim, check and set 1 to 3 units nose down. Check operation of the pitch trim indicator and set it between -1 and -3 units down. With trim at -3 you will have a nose-heavy tendency on the takeoff roll, which quickly approaches a trim condition as the aircraft lifts off and gear and flaps are retracted. With -1 trim, a very marked nose-up trim occurs beyond 230 knots during takeoff, requiring a large nose-down trim change at a very low altitude. Since the aircraft does not have indicators for rudder and aileron trim, ask the ground crew to check those trims being at neutral, by selecting crew chief, then ground checks, and finally select trim neutral. Press spacebar once the crew chief reports that the ailerons and rudder are set at neutral.
Ailerons and rudder, neutral.
IFR door and exterior air refueling lights, check if required. If you will be having in-flight refueling on the next mission, cycle the switch to check that its door and lights work. The ground crew will report their operation.
Door
Press
open,
spacebar
sir.
to continue.
Door closed.
Pneumatic pressure, check. The pneumatic system provides high-pressure air for the normal and emergency operation of the canopies, and the emergency operation of the landing gear and slats flaps. Normal system pressure range is from 2650 to 3300 psi. Press spacebar to continue. Altimeter and static pressure compensator, SPC, set and check. The SPC is a regulating module within the air data computer, used to eliminate major altimeter lag during rapid changes in altitude. The CADC switch, located near the throttles, controls the functioning of the SPC. The switch has positions for reset correction, normal, and correction off. With the switch in norm and the SPC operating normally, major altimeter lag during rapid changes in altitude is eliminated. Set current altimeter setting on the barometric scale. For today's mission it is 29.92 inches of mercury. On DCS it is already set. The altimeter pointer should indicate the field elevation within ±75 feet. We are currently at Bodo, which is at 42 feet above sea level. Press spacebar to continue. Prior to each flight, the SPC must be reset by placing the SPC switch to its position, reset correction, and hold it there. The light, static correction off, should go out and remain out. Altimeter reading should not exceed 25 feet from the original reading. Once reset, engage the SPC by releasing the switch to its central position, norm. The altimeter should indicate the field elevation within 90 feet. The same procedure should have been done by the weapons system officer, on the back seat, and after the SPC reset, the difference in altimeter reading between the front and rear cockpit should not exceed 75 feet. Press spacebar to continue. ADI reference system selector, primary. Sets the ADI to gather its attitude data from the INS, but be sure that the INS alignment has completed. The ADI and HSI will adjust to the new reference attitude. Wheel chocks and ground interphone cord, removed. The cold start is finished. Ask the ground crew to remove the wheel chocks. Press spacebar once they have been removed.
Roger. Wheel chocks out. You're all set, sir. Good to go. Have a safe flight. Disconnecting.
Congratulations, you have successfully completed a full autonomous cold start, with all check steps and employing no ground equipment. It's been a long lesson. Take a rest break before attempting the next taxi, takeoff, and climb training mission. Press spacebar to exit.